This video is part of the Introduction to Computing System Engineering course and covers the lecture on computer architecture. Looking at the course structure, you see that we covered a large part of the hardware hierarchy. In the course, we designed chips, logic gates, and also a part of the hardware platform. We designed the arithmetic unit and the memories. We also discussed the machine language that we will use to program our computer. So now it's time to define the computer architecture in detail. And with that we will complete the hardware hierarchy of our computer. So this is the lecture plan. The first video gives an introduction, and then in 2 additional parts we discuss the implementation of our computer. The history of computers started long time ago. So even though we will not build a mechanical computer, it's interesting to look back how they actually looked like. Okay, so here we have 2 interesting examples. One of them was constructed by Pascal, actually with really early age, and well, it's usually called Pascaline or Pascal calculator. It could add and subtract, and the goal was actually to help his father's calculations for taxes. It is mechanical, and 50 of them were constructed that time. Okay, and then with time we got more ambitious. So this Pascal calculator could only do some small set of given things. But then the goal was to build programmable computers, and the first programmable computers were also mechanicals. Okay, so here we have an example. It's Babbage's analytical engine, actually designed by Charles Babbage, but then finally completed by his son. Okay, this machine was already programmable. Well, what we will work with electronic digital computers, and there we will follow the architecture that is defined by von Neumann, and the idea is the stored program concept. Okay? The stored program concept means that both the program, the program code, and the data is stored in the memory. Okay, so data and instructions are stored all in the memory and can be manipulated. So then the idea of the operation of the computer would be the following. The memory contains the instruction, and then the execution of an instruction involves the following steps. The instruction makes the arithmetic unit to compute some function, and then write some registers or maybe some output device. And as a side effect of this calculation, figure out what is the next instruction. Okay, and then fetch the next instruction from the memory. So this is the computer and the execution logic that we will implement. Let's see how can we do that. We will use the chips that we built during the course, specifically the arithmetic unit, registers, RAM, and program counter. Okay, so using all this and well, some simple elementary logic gates, this time we will build the computer architecture. It will need some additional units, the memory, the CPU, and finally all this combined to the computer. So we will call our computer as the hack computer. Let's see how it will look like. It is a 16-bit computer, as we already discussed when we defined our machine language. The length of the instructions and the width of the memory are all 16 bits. We follow the von Neumann concept, that is, the program will be stored in the memory. Actually, the program will be stored in a separate instruction memory. So we will have instruction memory and data memory separated. It is actually the so-called Harvard architecture. We will design a computer that executes programs written in the hack machine language. Hopefully it will be easy to build from the chipset that we know. And of course it will build on sequential logic. So a clock will be implemented in this computer. We will assume that this clock is implemented, so we won't implement it ourselves. So what are the main parts of this hack computer? The instruction memory, where the program will be loaded, the data memory, including memory space for data, for the screen memory map, and for the keyboard memory map. Then we will have our central processing unit, including the arithmetic unit, registers, program counter, and the control logic that makes all these parts work together. Okay, and then from all this we build our computer. So let's look at the parts of the computer one by one. Let's look at the memory first. Okay, so in the memory we store data in the data memory and instructions in the instruction memory. Both of them are 16-bit binary numbers. Both of them are stored in a random access structure, which means that each of the words in the memory has an address and can be read. In the case of data memory, also can be written. The data memory, which is a random access memory, will contain variables, arrays, objects. Later on, right now we can only put 16-bit integers in the data memory. It has the input-output maps for the screen and the keyboard, and it can be read and it can be written. Instruction memory, it is a read-only memory. It contains a series of machine language instructions. It has to be preloaded in the hack machine. We will have jumps in the instruction memory according to the program execution. Let's look at the central processing unit, the CPU. The CPU will carry out calculations, will read, write the memory, and will make the computer jump to the right instruction. The CPU elements are the arithmetic unit. This will calculate according to the instruction. Registers to store some data and address temporarily, and the control that makes sure that the arithmetic unit and the registers do what it is given by the instruction. Okay. This completes the first part of the computer architecture lecture.